Welcome to this video on Type 1 and Type 2 error. By the end of this video, you should be able to interpret a Type 1 error and give a Type 2 error and give them examples of each in context. All right, so our scenario today is, should Rockford switch to bottled water? So the Wolverine Worldwide, which is a shoe company in Rockford, Michigan, improperly disposed of chemicals which have leaked into the groundwater. The state of Michigan says that if more than 7% of households in a city exceed the safe limit, the city needs to switch to bottled water. A concerned citizen took a random sample of 100 households, and he finds that 12 have unsafe drinking water. Do you think the data provide convincing evidence that Rockford should switch to bottled water? So if you're interested in reading a little bit more about it, there's a link on our Canvas webpage. And it shows you the full story about the drinking water and the toxic chemicals and more about the chemicals. And then here's our map. So here's the town of Rockford that they're talking about, and the chemical dump site is over here. But if you're interested in knowing more, there's a link to the article so you can read it. So first thing we want to do is we want to state the appropriate hypothesis for performing a significance test. We're going to use alpha 0.05. So we're going to have a null hypothesis that the proportion of the PFAS, those chemicals, is equal to 0.07 because the state of Michigan says that if it's more than that, it's a problem. So we're going to assume that it is that. So, and that means the water is safe. And we're going to have a null because we think something else has happened, because this guy got a p-hat of 12 out of 100. So he had a proportion of 0.12. So we think it's more than 0.07. So we're going to say that we think the proportion is greater than 0.07. Which means our water is unsafe to drink. All right, so anytime you write your hypotheses, be sure to define what that P means. And it's the true proportion of houses in Rockford with unsafe water. All right, so we've written our hypotheses, we defined our parameter, we have our statistic, and we would also, it says it right there, but just get in the habit of writing your alpha also. So after conducting a significance test, a p-value of 0.025 is found. So we want to interpret just the p-value. Okay, and so what this is this is the assuming the null is true. So assuming p equals 0.07 is true, there is a 0.025 probability of getting a p-hat equal to 0.12 or greater purely by chance. Okay, so that's the first part of when we're doing our conclusion, is interpreting the p-value. So if the null is actually true, because we always assume the null is true, there's only a 0.025 probability of getting the results that this concerned citizen got when he sampled the households. So are we going to reject the null or fail to reject the null? Meaning, are we going to keep the current water or switch to bottled water, and explain? So because I kind of keep us in our same conclusion kind of stuff. 0.025 is less than our alpha. That means we have to reject the null. That's pretty unusual results. And what that means is Rockford should switch to bottled water. All right, but what if we're wrong? What if he just had a wonky sample? It's possible. Nothing's really impossible. It's possible this happened purely by chance. It's just not very likely. So what if we're wrong? What would be the consequences of this? Well, if we're wrong, Rockford would have spent money on bottled water when they didn't really need to, because the water was actually safe, because our p-value indicated that we think that something's wrong with the water, but we could have been wrong. The water was actually safe, but Rockford bought a bunch of bottled water for their city and they spent money they didn't need to spend. If the water is safe, what's the probability that this error will occur? Well, what's your alpha level? Let's look up here. Our alpha is 5%. That's the probability of an error. So because our alpha is 5%, that's the probability that we could make that error. But now suppose the p-value is 0.217. Would we reject the null or fail to reject the null? Keep the current water or switch to bottle? Same idea. Go ahead and think about what this would be. Stop the video and give it a try and come back and see. Okay, so if our p-value is 0.217, that p-value is greater than the 5%, so we should fail to reject because the results wouldn't have been that unusual, and Rockford should keep their tap water. They shouldn't have to worry about the bottled water. But what if we're wrong? What are the consequences this time? So this time, if we're wrong and we say, Rockford, you're okay, drink the water from your tap, nothing's wrong with it, and we're wrong, it means people are drinking unsafe water. So that's a pretty big consequence. People are drinking unsafe water. And I mean, they're chemicals. I don't know how, they're not good for you, so they could get sick and maybe die. Those are pretty serious consequences. So up here, Rockford would have spent money they didn't need to. I mean, that's important to be fiscally responsible. But here people could die with this error here. So are the consequences in 2 and 3, which is more serious? Well, question 3 is more serious. Drinking unsafe water is bad for your health. All right, so let's talk about what this means in terms of what we've been doing. We've been running significance tests where we say we're going to keep the null or fail to reject it, or we're going to reject the null because we found convincing evidence of an alternative. But we can be wrong. We could be basing everything off of a bad sample. Okay, and so this happens, and so these types of errors have particular names. So if we look right here where we said we're going to reject the null, okay, that they should switch to bottled water and they shouldn't, that's called a type 1 error. So type 1, and they're usually written with Roman numerals. Okay, and what that means is your null is true, but we rejected anyhow. Even though it was true, we rejected the null. Okay, that's a type 1 error. And the probability of making your type 1 error is your alpha. Okay, so usually we have a 5% probability of making a type 1 error. That's a pretty small chance of being wrong, so that's why we're using this, that we feel pretty okay about it. Now, the other kind of error, that's what we dealt with here, where we failed to reject. We kept this null even though we should not have. Okay, and so that's called a type 2. Okay, and that is, so type 2 error. Your alternative is true, but we failed to reject the null. The alternative is true, but we failed to get rid of the null. So that's our type 2. Usually type 2 is a more serious situation, and we see it right here. In one situation, while wasting money is not a good thing, it's not nearly as bad as people could get sick and possibly die because they drink chemicals in the water. Okay, so usually type 2s are worse than type 1s, but we want to avoid making them if we can, and that's why we have to have good sampling techniques and all that kind of stuff. All right, so let's have a little bit of a summary here of our error types and how we want to talk to them. So let's go ahead and flip this over. All right, take a second to pause the video and copy this box down. We're going to make just kind of an idea of help you memorize the types of errors. All right, now that you've got this written down, so here we've got, these are our truth statements, whether the null is true or the alternative is true. And then these are really our decisions that we always make. Do we decide to reject the null or fail to reject the null? So if the null is true, but we reject it, null is true, but we say it's not, this is a type 1 error. Okay? We should have kept the null, but we didn't, we got rid of it. If our alternative is true and we rejected the null, that's exactly what should happen. If we find evidence for our alternative, we need to reject the null. So I'm going to put a smiley face here because that's what I want you to do. That's what we want to have happen. Okay, what if our null is true and we fail to reject the null? Well, that's also exactly what we want to do. If this is true, we want to keep it, so we need to fail to reject. So that we want that to happen. But if we look, if our alternative is true, but we keep our null, that's a bad thing. We don't want to do that. That's your type 2 error right there. Okay, so we really don't want to do these, but these are definitely what we want to have happen. They can, even with all of your best planning, errors can happen. And we'll be talking about power, and that will be related to how we can minimize our problems or possibilities for some of these errors. Okay, now the other part that I want to talk about here is when we're talking about describing a type 1 or a type 2 error, kind of what we want to look into. All right, the first one I want to talk about is our type 1 error. And remember, your type 1 error is your null is true, but we rejected it. Okay, the probability of a type 1 error is equal to whatever your alpha level is. Now, when we're describing the type 1 error, you're going to want to talk about how the null hypothesis, whatever the context is, everything has to be in context, is true. However, we found convincing evidence for the alternative, and all of this needs to be in context too. Okay, so the null hypothesis we had with the water is safe. The water is safe but we found convincing evidence there was too many chemicals in it. Okay, that's kind of how we would have discussed a type 1 error from the front. Okay, then we have our type 2 error. Okay, and now remember, your type 2 is your alternative is true, but you failed to reject the null. Okay, let me give you a little hint before we talk about how to discuss that when you're describing it. My hint to you is this. I write it up here at the top so you can come back to it easily. Type 2, okay, is going to be fail to reject. Type 2 is fail to reject. They both have these 2's in them, even though they're different things. That's one way to kind of help you remember it if you're really struggling with it. So, and usually these are the worst ones. And so what that means was the alternative was true, but we kept the null. The alternative is true, but we kept the null. Okay, and what you want to say here is you want to talk about the alternative hypothesis in context is true, but we do not find convincing evidence for that alternative also in context. Go ahead and try this, check your understanding. Be sure to come back and check your answers so you're on the right track. Let me know if you have questions. See you in class.